Thank you everyone for attending this session. The session is going to be for Samuel Mabakane. Session name is HPC Visualization BOF. I will introduce Mr. Mabakane. Mr. Mabakane is now a doctor, Samuel Mabakane, who holds a PhD in computer science from the University of Cape Town. He has more than 15 years of experience working in both public and private sector that offers technology services. He is currently a senior administrator at the CHPC, where he is responsible for the administration of HPC clusters. During his period at the CHPC, he has also acted as a technical manager, responsible for managing 8 senior systems administrators who work on different components in HPC, such as storage, network, and compute. In private sector, he was a systems engineer at the ATIO Corporation, where he performed administration of the call center systems. On the other hand, he has published a number of theses and journal articles focusing on the performance analysis of parallel programs running on the supercomputers. He has also developed an effective core graph network visualization used to identify performance bottlenecks for optimizing parallel execution of applications. I hope I did.
Okay, thank you, Zama. Oh, no, I do have it, Mike. Thank you, Zama, for a wonderful introduction. I was supposed to facilitate this session with Matthew Wolf from Ukrish National Laboratory at the United States of America, but unfortunately, he could not be able to join us due to unforeseen circumstances. Nonetheless, I've asked my colleague, Zama, to assist me in facilitating this session. And my talk today is entitled Proposed Design of the Visualization System for CHPC. In a HPC field, visualization systems are usually used to analyze scientific data and performance metrics generated by parallel programs running on the supercomputing systems, such as distributed memory, machines, clusters, and hybrid systems, shared memory systems, such as SMPs, and vector systems. These visualization systems are expected to be informative, interactive, and also easy to use when one analyzes the data on the system. But we know this is not always the case due to various factors such as the performance of the visualization system. At CHPC, parallel computing users visualize scientific data using their own desktops and laptops, of which these computers have got limitations, such as a small screen that is used to display the information, and sometimes it is not easy to view different views of the visualization and also get insight information when you are using a small screen. And then the other issue is the limited memory capacity when you are using laptop or a desktop to visualize applications. So, and the third one, it is the speed of the processors, which are not much higher as compared to when you are having a system, a full implementation of the visualization systems that is running on the either connected to the cluster. And then the last point is also the performance of the network. You need a very good network, especially when you are going to visualize your data in real time. So sometimes it can be an issue for those people who are not having a good network connected to the cluster, especially in our case at the CHPC. But we do have a very good network system that we have put in place. So these are the challenges that most of the visualization users are experiencing when they are when they are visualizing scientific data on the CHPC systems. Another thing is that I don't want to go a lot and talk about the background information about visualization data, because many people do have a knowledge about this field, but I just want to highlight the experiences that we have about visualizing data on the CHP ceiling out cluster and the old systems that we have, such as the E1350 cluster and the Sun microsystems. So currently at CHPC, the users utilize different methods to visualize data. And one of these methods is that they run the application on the system. After that, it generates the data. And then they download the data into their respective laptops and then visualize this data using the tools that they've installed in their laptops. That is one method that our users are using to visualize data after performing or running the runs on the system. And then the other option is that we've got a few GPU nodes that are installed on the CHP ceiling out clusters. So some of the users take advantage of these nodes and then utilize these compute nodes to visualize their scientific data after the run. But of course, these GPU servers are not a full implementation of the system where you will be able to interact with that particular system. And it is also not informative in this case. So it's just a bunch of GPU servers connected to each other and then assisting in terms of memory and so on, and graphical processing. So the CPC, based on these challenges that the users are having, have decided to put up or set up a visualization system. And this is a plan. So having this plan in mind, we decided to conduct a survey about the plans to set up a visualization system, either at CHPC or at CHPC as well as in other different locations. This is why actually we are here to engage with the users on the kind of a design of the system that they like to see or they would like to have at the CHPC. So during the survey, users from different institutions such as University of Cape Town, University of Stellenbosch, as well as TUT, and also all these different universities that we have in South Africa, and including the research organizations such as CSIR, participated in this survey. And the aim of the survey was to establish the following: which design of the visualization system will suit our users? And the second one, what kind of visualization services does our users need? Those are the two key things that we wanted to answer with our survey. And then we proceeded to set up an online survey. And then afterwards, we have sent an email that was in June and also July 2020, which is this year. And then on that survey, we have asked our users to provide answers to the following questions. First one, does your project require data visualization? Secondly, how frequently do you visualize data? It means how many times do you visualize data on the ZPC systems? Do you require a large screen to visualize data on the systems? That is the third question. And then the fourth question was, do you need accelerators such as the GPU to visualize data? And then the fifth question was, what software do you intend to use for visualization in the new visualization system that we plan to set up at CHPC? And then the sixth question was, what would you like to see in a new visualization? Basically, this is a wish list, the last question. We want the users to tell us what they want to see in the new visualization system, how they want the system to look, what kind of softwares they want in that visualization system, and then how it should also interact with them. Like I've already mentioned, that the visualization system should be able to be informative meaning that it should provide useful information to the user. And then interactive relates to the exchange of information between the user and the system. And lastly, I've also mentioned about the easy to use system. Simply means that it should be simple to use that particular system. So those are the three things that I act as a baseline when you evaluate a visualization system. I know there are many methods of evaluating the visualization system, but those are the just general things that you should look at when you develop or design a visualization system. So we had these 6 questions, we posted them to our users, and then that was in June. We received about 32 responses. And then we found that that was a very low number. And then we sent another email in July, towards the end of July, and asked our users to again submit their input with regard to this survey. And then we then end up with 79 responses. So that was a better number, especially compared to the previous surveys that we conducted at HPC. We don't normally get this so many responses. 79 users who responded to this call. That's a very good number and an overwhelming number, especially when you consider that most of the people surveys, they do not really pay attention to. And sometimes because they are busy or they just not interested on the topic that you are talking about. So we found that it was a very good, successful survey. And then now we are going to talk about the feedback from the users who completed the online survey. You would recall that I've mentioned that users were asked to submit or provide answers to 6 questions. And the first question was, does your project require data visualization? This graph shows feedback from the users who completed, who responded to this question about does your project require data visualization? In the, in the x-axis of the graph is the response or choices made by the users. And then on the y-axis of the graph is the number of responses from the users or number of users per response. And this formula is going to be applied in almost all the graphs that I'm going to talk about in some few minutes. And then what we see here is that out of 79 users who submitted their survey about this question of does your project require visualization, we noticed that 72 out of 79 indeed do require data visualization after running or simulating the applications on the system, of which, very small number also, 7 of them, they said that they do not require any data visualization after running the simulation or even after optimizing the application or even after optimizing the application or making changes in the applications, because our users regularly make changes in their configuration sites. For example, if I'm running a weather-focused model such as a WAF, I will be able to design different grid sizes. And then every time when I run a different grid size, it means I'm making the changes on the configuration of the application. The same applies to when you are using the material science applications such as DL Poly. People do actually use different number of atoms such as oxygen and nitrogen and so on and so on. So those are the things that normally users are used to make changes in the systems, in the applications in order to get their scientific results. So this number 72 is very important to us because now we know that most of our users do require data visualization and do want to perform data visualization. And in fact, they are performing data visualization currently with their respective laptops. This is very important. So we are in the right direction. even though, of course, there are also other small number of around 7 people who also indicated that they do not require data visualization. Applications are different. Other applications are not complex to the point that after I run a simulation on the system, then I need to visualize the data in order to see or to make to see the calculations that were performed on the system. So that's why you'll have some users who do not require visualization tools or a visualization system. And then we also look at this part on how many times does our users visualize their data, you know. And then in this graph, you can see about 31 users did mention that they perform their visualization of data on a regular basis. I think daily is just basically meaning on a regular basis. And then about 18 users also indicated that they are performing the visualization of data on a weekly basis. And then on the other hand, about 5 users indicated to us that they perform the visualization of data after the runs, and then 3 also for on a yearly basis. And then we also had another interesting one, which is after the run, like immediately after running the simulation, do you immediately run the visualization? And then we had about 6 people who indicated that they do they do visualize or perform data visualization after the runs, and then 1 user after optimization. This is very interesting because we know very well that most of our users do not optimize their applications for scaling or efficiency on the system. Most of the users, they dump the application on the system, and then if it does not scale, they increase the number of nodes, then hoping that they will be able to get a better scaling. So that's what normally happens. Only few users do optimize applications at HPC. So that's why we've got only 1 user who indicated that he once visualized data after optimizing it, the code. And then we had about 4 users who said they were not sure about how frequently do they visualize the data. And this is the kind of information that we also wanted to know. Do they know how frequently do they visualize data? And then we had about 11, obvious, which is not here, but if you make your calculations, you'll notice that actually there is 11 responses that are in short here. So 11 users did not respond to this question. You know, so not all the questions were responded to during the survey. And then the third, excuse me, let me just make sure. Okay. The third question was, do you need a large screen to visualize data? In this case, we also can see that 41 responses were recorded for yes, which means that 41 users, basically, they do say that they require large screen to visualize data. And then 38, which is almost the same, close to that number of 41, also said that they do not require a large screen to visualize their data. This is interesting, but we also know for a fact that at HPC, we've got a variety of applications. There is applications that generate complex data, and one cannot be able to visualize it, or it is hard to visualize that kind of an application in a small screen because you are not able to see the inside of information. And sometimes if you are using a interactive visualization system, then you'll be able to see more information or even to get more information about the data that was generated by the application. But on the other hand, we also have users who the applications are not complex. You know, like for example, if I'm running a DL poly, you know, I just, when I visualize the application, visualize the output of the application, it does not really require a large screen because it's just a small box, you know, with different types of atoms, you know. So, but it is different when you are running an application like a CFD application, like a weather application, such as a regional oceanic model or a WAF, and so on and so on. So that's why you've got these numbers, which is almost the same, because we've got different types of users who actually are running the applications on the system. So it makes sense to us. And then the fourth question was, do you need accelerators such as GPUs to visualize data? And once again, we also see that for the two responses from the users did indicate that they would like to have GPU accelerators in order to visualize their data, of which 37 users responded that they will not like to have a GPUs or they do not require GPUs when they visualize data. And once again, in this case, it shows that we have different applications. Other applications are memory intensive, others are not. And some applications that are memory intensive, it will be best if you run that applications on a GPU system or on the GPU servers that we have available. And even in future, when you visualize the applications, if it requires a lot of memory, yes, the advice is that you should be able to use the GPUs. So these are the things that we're exploring, in order just to find out what would users like to see in the new visualization system that we plan to set up at HPC. And then the fifth question was, what software do you intend to use for visualization? In the x-axis of this graph is the names of the softwares, visualization softwares, and on the y-axis is the number of users who recommended that particular software. So we've got a few softwares that were recommended here: Python for data visualization, and then you've got ParaView, very interestingly, because also one of our international collaborators that we are working with from Ugrich National Laboratories, they also recommended that we should look at ParaView as one of the visualization tools that we can install for interactive and visualization. And then you also have other users, a couple of users, which is about 9 users who also recommended CCM Plus. And then you also have other users who recommended Gaussian view or Gauss view, and then XCrystal. And then about 5 users were not sure which software they would like to use for visualization for visualizing data on the new visualization system that we plan to implement at HPC. And then it is about 55 visualization softwares that our users have recommended that we implement on the new visualization system that we plan to set up at the HPC, or that we plan to set up either at the HPC and other remote sites. So, and that includes softwares again like Vesta, VMD, Discovery Studio, Material Studio, Origin, ANSYS Mechanical and Fluent, GNU-Blot, CRES, MS Excel, interesting, Schrodinger, Jupyter, and so on and so on. It's about 55 of them, that they've recommended that we should install or have in our visualization system if we end up having that system at the HPC. So yeah, with that, we then asked our users the last question, which was, what do you like to see in a new visualization system? So this is a wish list. We want them to express themselves and tell us anything that they would like to see in their visualization system that we plan to implement at the HPC. And what I did here is that I've simply copied the user's response and pasted it in the slides. So the information that you see here is exactly what the users have said when they were submitting the survey. And these users would like to see the following. Firstly, They talked about remote visualization, means they would like to have access to the visualization remotely. And then easy, quick, and stable visualization. They would like to have a easy to use visualization, which I spoke about at the beginning of the presentation, that you need to have an informative, effective, interactive, and easy to use visualization. So because we don't want to end up with a situation where now our users, now their job is to actually visualize data. They are struggling to visualize data. Someone takes years to visualize data. While they were visualizing their data in their laptops easily, but now you develop a system that is so complicated for them to use. So we want to develop something that is going to be easy, not become a burden for them when they visualize data on the system. So this is what we have in mind. And that's the reason actually we are having this discussion today. And we like the views and also input on how we can be able to implement that kind of idea that we have in our, that we have at the ZPC. And then other users, they talked about interactive visualization. They would like to have an interactive visualization. And then they will also like to have a dedicated nodes or queues with access to GDLA and ArcPy. I think GDLA is maybe, this is a Python, this is a Python library, but I'm not sure about it. And then overall GPU support, not only for visualization, but also for computation. A tool to visualize generated images from simulations such as PPN or PNG files. A ParaView server for efficient remote or in-situ visualization of large runs. I've already talked about the ParaView, that there were most number of the users who responded to the survey did indicate that they would like to have a ParaView as part of the a visualization system that we intend to set up at ZPC. And then other users also talked about the solution to the QT55 MESA or VMC incompatibility, Gauss view for Gaussian 16, dedicated hardware and data bricks or ParaView with working examples, software to capture screen images so that we can image to publications, common software for visualization of quantum chemistry calculations. So you can see that we've got a variety of users. You'll have a chance. I'm going to just run through the slides, and then I'll give you a chance to ask questions and also have some suggestions. And then you've got a variety of applications. You already see that other users are talking about Gaussian, and then also while we also have other users who are quantum chemistry, but it doesn't mean really that they are using also Gaussian. It might be that they're using other applications. And then we've got a variable color. Some other, one of the users also mentioned about having variable colors and 3D images suitable for paper publication. And then high resolution screen. They would like to have a high resolution screen, high quality graphics, increased GPU capacity. Technical support is also crucial. They believe also that it is important that they find people who can be able to provide them with support when they are experiencing difficulties in visualizing data. Flexibility, variety, storage, and visualization export facilities. System that is able to process and visualize big data faster and efficient. This is one of the recommendations that the user have stated. Lot of storage space for data. They require a lot of storage to store the data. And then large computing capacity for CFD simulation. Then I think this is the last part. Simple or customization interface that can generate publication visualization. You'll notice that this with easy to use, easy, simple, interactive. This is the way that keeps on coming in our survey that was conducted. So many of our users, they want that kind of a system, either a simple one or an interactive visualization. So those are the things that they wish to have in our system. And it's very interesting because indeed, when you are building a visualization system, you want to have a visualization system that is not going to be a problem for your users, because their duty actually is not only to visualize data, they also have to perform calculations on their system. And then visualize data in Python. This was also mentioned in the previous graph, that users would like to have a Python in data visualization. And then more memory and more available in the compute, more power and memory available in the compute nodes for visualization. Data dashboards that monitor the progress of simulation while they are running. Visualization of high resolution model output evolving in time, and large screen and presentation. So this is the list of wish list from our users. I did not edit these responses. This is exactly what they've mentioned in the survey. So when you look at all these wish lists that they've provided to us, is it possible to do them at the same time? That is the reason we are here. We want to engage with our users and understand if it is indeed possible to be able to develop this kind of the visualization system that can be able to satisfy their needs. And then design of the visualization system. I've put a question mark in this slide because we are still at the early stage of developing the visualization system. We do not have enough information to provide the design of the visualization system at this stage. However, we are working with our colleagues at Oak Ridge National Laboratory, who also are advising us about the kind of design that we can be able to set up for our users. I did share this data with Matthew Wolf from Oak Ridge National Laboratory, and then he also found that the survey was an indication that users are interested in the visualization system at HPC. So, but we are still in discussion, and hopefully when time goes on, we will be able to have a solid visualization design that we can be able to present to you. But safe to say that Matthew and also Eric, another person called Eric Smith, those are the people that we are working with and advice that we are working with, because they are advising us on the kind of visualization system that we can set up. I heard that it seems like one of them resigned and so on and so on, but I don't want to get into that. Yeah, so, but this question mark is about asking questions. What kind of a visualization design do we want to have at the ZPC? What kind of services do we want to have at ZPC? Or what kind of visualization services do we like to have at the ZPC? So that is the reason actually we have hosted this bit of a further session to discuss and engage with our users. And with that, I think I've run through all the slides, and then I'm gonna open the floor for questions. Yes, and I think first question there, or the suggestion.
All right, so Scott Klasky from Oak Ridge Lab. Matthew used to work for me. So, so essentially my group was the research and data management visualization. Now we've bifurcated. So if you want to learn more about Oak Ridge really from what we're doing, you should talk to me, actually.
Yes. Great.
Because I'm kind of in charge of a lot of it, along with one of my colleagues, Dave Pugmire, but Ken Moreland's there. The other is, like, I was actually showing Jay, like when you talk dashboards, it's hard to see this because it's on a little phone.
Yes, bring it on.
But it's a easy to use interface to click and drag kit where the guys who do ParaView, they're developing it with us, but it's a way to monitor simulations. The other thing to point out is, like, when you talk about in situ with ParaView, one of the things we've been doing is connecting them through Adios. And if you don't know it, I'll talk about it at 12. but basically it's an in situ wave where you can do it with Catalyst if you're familiar, and those who not, it means directly in memory. So you're using the same nodes that you're computing, or you can do it what we call staging, where you can have separate nodes, separate cores, or even a separate viz resource, which we have users from JAXA. So there's a lot of advanced things, and probably from the Oak Ridge perspectives, the people to talk to, like you mentioned, Eric, who works for Dave Pugmire, who then, works for me. So just talk to me and I can try to guide you more like a little later today.
Okay.
Because there's a lot that I can tell you.
Okay, thank you very much. This is good news, because now I actually just find the person who is responsible for the visualization systems at the Oak Ridge National Laboratory. I did, by the way, I think it was in 2012 or 2013, I did visit Oak Ridge National Laboratory, and then they showed me their visualization system, which was named Vista. Yeah.
It's Everest, really.
Everest, yeah. So that, and then I think it was a very interesting system to have. But you have also indicated some interesting topics about ParaView, which will it be able to give us the kind of an in situ visualization system that we want to develop at the HPC, because our aim is to have an in situ visualization system which can be able to visualize scientific data in real time while the simulation is running. And at the same time, we also want this in situ visualization system to be able to track the performance of the applications in real time. So those are the two things that we want to have. So I wonder if it is able to manage to perform this task that I just talked about.
Again, I show this stuff, and okay, so Adios is an IO system, so it's self-describing data. So one of the things, and I mean, Jay was one of the creators of it when he was a student a long time ago.
Okay.
So he worked. So basically, you have very efficient IO where you get terabytes per second going to storage on the larger systems. And you understand SKA is using Adios as well. So this is highly integrated. But now, instead of going to storage, now, TAU, T-A-U. So you mentioned performance.
Tau, yes, I know.
So now TAU actually talks and writes to Adios. And what this does, instead of writing to a file, now you have a schema. And the other thing you should look up is something called FIDES, F-I-D-E-S.
Yes.
Okay, so now you have a schema though that comes from TAU. And now I showed this actually in supercomputing. We had an Adios tutorial with ParaView and with TAU. And now what you have is the performance information that comes when you run with TAU exect. That information is then published, and then you can see it. Then we have a dashboard. You can go to esimmon.kitware.com,
yes.
but you can just search for it under GitHub. And now what you can do is all of the visualizations can then be monitored in a web interface. So then you can have 1 to dozens of people coming up during the simulation who are collaboratively visualizing the data. So what I'm trying to say is we have a lot of solutions that even Matt did not, he didn't really know much about. But if you really wanted to know, and the people, there's myself, and really I would refer you to Dave Pugmire, P-U-G-M-I-R-E, along with Ken Moreland, who's one of the ParaView creators and leads the VTM project, because the other thing you said was GPU enabled. And what they've been doing is some of the underlying algorithms that they're dealing with. The other side that you should be familiar with is we've been putting a lot of reduction. So then when you visualize, if you're just trying to visualize, there's things that you can do that can greatly accelerate the visualizations by looking at reduced representation that then visually will look the same.
Okay.
So then you can greatly speed things up. There's a lot of things going on that you probably should talk to me when I'm here, but I'll refer you to a lot of the more junior people who will have more time than me to answer when I'm not here.
I'll appreciate that. Thank you. I'm glad to have got somebody like you in this session, who is able to assist us with a lot of information that we require in order to set up a visualization system. And definitely I will be able to talk to you after this session so that we can map a way forward on who to talk to at the Oak Ridge National Laboratory, and then and so on and so on. You know. Yeah. Yes, yes, yes. And then while it's still on the platform, how is the ParaView different from Vega visualization? A Vega. Vega. It's called the VEGA. Yeah, because Matthew did mention. Yeah.
No, that.
Yeah.
Okay. So again, Matt's not a Viz guy. I want to just point that out.
Okay.
But let's. And again, if you want to look at Matt, look at his papers, and you'll see with Jay, you'll see with me.
Okay.
So what I want to point, what you mean, I believe, is called Visit, VISIT.
Yes.
It comes from Livermore. Now,
I heard about it.
So it's not Vega, it's Visit. Now, Visit is something where, again, Visit was also with Oak Ridge, Dave Pugmire, the guy I mentioned. He was one of the main guys on that, along with some of the other guys I work with. But Visit has not been advancing as much as ParaView. So now at Oak Ridge, it's pretty much we're going over to ParaView. So even though we have Visit developers, everything's going ParaView, especially with Ken Moreland, who used to be at Sandia with Jay, but then we stole him from Sandia. But Ken is also excellent. And, you know, again, we work very closely with each other. So ParaView really is the one if you want to focus.
Yes.
And then, as I said, for the in situ, there's Catalyst, which they do, but what we demonstrated in a supercomputing tutorial is now, if you have Adios, now what you're doing is you're saying all my IO is going to be self-describing. And do you know what I mean by self-describing?
What do you mean?
Okay. I feel like I should not be in the back. I'll just come
to
the front for a second.
Come
but
over.
Just because I don't want to hurt everyone's neck. Like, so what I'm talking about here, and you know, is what you want for self-describing data. And what we've been trying to push from Oak Ridge from the perspective is, imagine that you have a live experiment, right? What you want to be able to do is, for those who are older, we remember at an oscilloscope, you want to just probe into that data. You can't change Mother Nature. The same way in a simulation, imagine you program it that it publishes all the data. So let's say you're looking at some CFD calculation. You have a variable called temperature. You have a variable called pressure. You have entropy. You have velocity, right? Those are just some variables. Self-describing means that anyone can come in and you can see there's a variable temperature. You could have what we call domain decomposition, and you can have even with holes. So if you think of everyone here with all the seats, all you guys can be thought of as processors. And then what you can have is like data on each one of the processes. Now for in situ, since this data is essentially just, we call publish subscribe, now everyone can just say, I want to in situ viz. And I just want to see it in that portion of the room. That data comes over, and now you have a choice that you can do when you hook this up with ParaView. So now what you can do is you can say, I can do that where the computation stops, right? You're running on the GPU and CPUs.
Yes.
You then run the Catalyst plugin, and now you create the visualization, which then is published, or you have the image, or it goes to a dashboard. That's one way, but then you can do another way. You can have that where now the memory is just going to separate cores on the same node, but it's asynchronous, which means now you can be playing with ParaView, and now you can be moving the object around, but the simulation just continues. Now you can do a different way. You can say, there's one node that I'm going to run ParaView, or two nodes. That data goes over through the network. through what we call RDMA, remote data memory access, right, or MPI. And now you can visualize there. The simulation keeps running.
Yeah.
And then when you want to see like, oh, data from a new, say, step data,
Yeah.
and then you say, let me get it. The data comes over, but you don't interfere. So we're providing all these modalities. And when I'm saying this is the modern way, so we can talk more later if you wish.
Okay, thank you. Oh, you can give it to. Oh, thank you, Scott.
I have a question from the online thing.
Yes.
The question comes from Samuel Mateja. He's asking cloud to edge visualization. Are other users asking for this? What suggestions or ideas are there for this?
Can you repeat the question again?
He's asking about cloud to edge visualization.
Yeah.
Are other users asking for this? What suggestions or ideas are there for this cloud to edge visualization?
Yeah, we haven't actually had any users who talked about cloud to edge visualization from the survey that we have conducted. So the answer is we don't have any users currently who actually talk about cloud to edge visualization. Most of the users, they talk about the interactive visualization and also the easy to use visualization that I've talked about. And very interestingly indeed is that most of the users, they are interested to have a ParaView, which seems to be a very good visualization tool currently that is leading the data visualization. So the answer to that question is that we don't have any users who are currently talking about who recommended the cloud to edge visualization. Any other question? Yes, Charles?
Okay, thanks. Well, I've got a lot to say, obviously. I've been at CHPC since 2013, so very intimately familiar with what the users need. So there's so much that we actually need to unpack about the whole question of what kind of visualization system we ideally need. So one question that needs to be put to one side and definitely it receives special attention is there a business case for a hardware-based visualization room somewhere? In other words, a large, I know you've been thinking in terms of a large wall screen where users can come and visualize their data. So that's the first thing we've got to find out from people. Is there a business case for that? Is this what people want? Or are people wanting to sit at their own campuses or at their own offices working with, when they say a large screen on their desk? So that's one of the business cases that you actually need to find out. Is that what we want?
Yes.
And then secondly, I do think from Oak Ridge point of view, you do need to understand we operate at 3 orders of magnitude less infrastructure and intensity of use from our users. So we have a range of users and we have a large number of users with minimal requirements. And then we have a small number of users with reasonably large requirements, but nothing that gets up to the kind of scale that you refer to. So the next question, and actually a question I want to pose to you is, in an environment like that, what we need a lot of is remote desktop style visualization for the users at their various campuses or offices. And what we've been using is an all open source stack. So it's VNC, virtual GL, that sort of thing. We do have some limitations with it. So we do run into certain problems. And I'd quite like your thoughts on what you would recommend from your point of view about the remote visualization point. So ParaView we've had on the system for as long as I've been at the CHPC. And we have a lot of users making use of it, but less than you would anticipate. So when we ran a workshop back in 2017 at this conference, we were just basically demonstrating to people, how do you do remote parallel visualization with ParaView? I think we had about 4 people pitch up.
Oh.
So the facility is there within the restrictions of what we have in terms of the hardware. And when it comes to new hardware procurement, we need to figure out exactly what we need to take it to that next step. And we need to find the users who've got the case for doing the really large kind of remote work like that. And then we need to distinguish also from our users 3D visualization, something that you need processing power behind that can handle OpenGL, and 2D maps, which is typically what we get from the weather people. Because it's got such a different underlying hardware requirement. So those are things we need answers to.
Okay, Scott, do you want to answer?
Okay, I'll try my best. As one of the first people who put one of these big walls, and knowing, like, again, I mentioned Dave Pugmire, he's the one who assembled the wall. I'll tell you what he says about the wall. If you make him pay attention to it, he'll leave Oak Ridge. If you actually look at Everest, which is a large visualization wall,
yeah.
Do you know how many users come on average per month? It's somewhere between 1 and less than 1. Now, the politicians love it. They love it because look at this incredible thing. And the most common use on Everest, PowerPoint. So when you ask me about it, and I know, again, who's the person who was the head of LBL, NERSC, same thing. They don't want to touch it. I made one, and again, it's the same thing. I don't want to touch it. So do I have a strong opinion of it? But I love large screens. And again, it's like you just need scalable viz. So that I get.
Yeah.
But that I'm just saying, the scientists who come to me are similar to what you're saying. If you think everyone at Oak Ridge uses like PowerView, I keep asking, look at the publications. How many 3D viz are in the publications? On average, maybe 1 out of every 5,000. So you use it to help you hone down on where you're going to then see and visualize and then be able to do your analysis. So it's very useful. In terms of the remote, I mean, PowerView has a remote interface. It works quite well, but it's a very personal one-on-one experience, and it's more for 3D. You can do 2D. So we use more of like Matplotlib. So my personal belief, and again, I'm not saying I'm right, but see, I see as a mixture from Python notebooks, and I see the future is these collaborative dashboards and ways so that when people publish, they can see 3D, but they publish it because what we see from knowledge is it's all collaborative. I have experts from performance, from different pieces of physics. So when you have these collaborative dashboards, a lot of the physicists, where the project's mostly paid by a fusion physics project that I'm on, I mean, it's like people see that as you want to have a simple way that has the simple visualizations. There's also another technology, my God, Jim Aaron stuff. I'm forgetting the name of this, but
yeah, you can tell me that name later on when we have a chat.
I'm a little sleep deprived, so
if you don't recall it now, it's fine.
I just can't recall it. But again, I say, so again, I'm saying the remote viz. Again, I think the personal stuff with PowerView, the MATLAB, the Python Matplotlib, that's what we see people using. Those are the things that we see people coming to. So depending upon, do you want 2D, 3D, and then you can do all those remote. And then just having quick data, access to this. And then the shared, you use VNC, but I can't remember, there's other technologies similar based. So we use all that. So, I don't see us, and if you think of we're so bleeding edge, and then think, but the majority of the people working on our systems are doing Matplotlib Python notebooks. Okay.
Thank you very much, Scott. Before maybe I take another question, I just want to make a comment regarding what you just said about the remote visualization, because what we want to look at is that like Charles said, it's about the business case. Do we need the large screen? Do we need to have remote visualizations on different sites, or do we even maybe bring a kind of a system like where we can have a system at a CPC and then we have a subsystems on different locations like hotspots where we know that most of our users require that visualization. So those are the things that we want to engage about, but I have a sense when I'm listening to some of the things that were said by Scott, that it seems like it just depends on your users' requirements. What does the users require when they visualize their data? Is it wise actually to have some little box where they can just simply run their visualization, or maybe also to have a large presentation? And it's right, indeed, politicians like, very big, good pictures, and CPC, unfortunately, it is not immune from that, because CPC, it is a government agency which is fully funded by the government. So one of our stakeholders, it is the government politicians. So it is not a secret about that. So when we have something that also can give them a pleasure, it is not a waste at all, But yeah, let's have the next question.
Yes, from Zoom. Again, Samuel is asking a question to Scott. He is asking about remote VR interest in Adios to drive adoption. Remote VR interest in Adios, ADIOS.
Yeah.
No, I know, that's mine.
Adoption.
But where I'm thrown off again is the virtual reality part. So I need more details on what they mean by that. Because virtual reality, right, it's a technology that people use, and you can have, headsets for that, right? So, I mean, I'm going to refer to Jay. Jay,
do you want to answer that? Okay.
I just need to know what they mean by virtual reality. If I can.
Yeah, I think.
Well, that's what I'm asking. If they could.
Samuel probably, or Sam, is able to hear us. So let's hope that he will be able to clarify his questions to us. Is there any other questions online?
Not yet.
Oh, okay. Great. Okay. So we had some discussions, very interesting discussion indeed, about the design, basically, what kind of software stack we can have, and also the kind of setup that we can have when we implement the visualization system for CPC users. So, but I think we did not talk about the services, the services. What services would users like to see at CPC? They've mentioned some few of them in the survey, which I've captured in these slides, but I thought maybe we can also be able to tackle that question, and what kind of visualization services will you like to see, or will you like to have at the CPC? Is there anybody who want to jump into the floor and then provide answers to that? Okay. Oh, take the mic first, because we are also online. Yeah.
So I just have a question based upon your results of the survey. If you go back to the slide that showed the respondents and the long tail, yeah.
Which one?
No, the other one, the one you had before.
Oh.
The one with the long tail. All the different options.
All the different options.
Yeah,
Okay.
so when I look at the slide, what I infer is that the majority of our client base, in actual fact, have their own tools.
Correct.
And very few are using some common tool, which is either Python or ParaView. So the question, if the majority of the researchers are comfortable, and I don't know if they are comfortable with using their own tool sets. Then what is the benefit of developing a single tool for everybody if the majority already have decided they're using their own tool? Or, I don't know, is there any deficiency in what they're currently using? Do they want a centralized tool? And I don't know if that is answered in the survey question. Do they want a centralized tool for all the users, or they're happy to kind of use what they have? Because if you're going to go the route of investing in a centralized tool with VNC, are you going to get the usage that you need based upon that particular slide?
I'll answer that question. Thank you. Yes. The question is, do users actually, since they've got this visualization software in their own laptop, do users need a centralized visualization system? And the answer is yes. And I'll tell you why I'm saying the answer is yes. If you look at the systems at the ZPC, we complain a lot. I'm sure that you have also received some of those emails, which say that we are running out of space. We are running out of space on a regular basis. Almost once in a month or twice in a month, the research manager will send an email that please delete your data. What is it that is generating this data? We've got 4 petabytes currently. Previously, we had 480 petabytes, and we increased it to 4 petabytes, but we still have the same issues. It did not solve the problem by increasing the capacity of the storage. That is number one. Then I want to explain to you why indeed we need a centralized visualization. Because if we are developing the kind of an in-situ visualization system that I have in mind, is that the user should be able to make changes on the fly in the applications, and then doesn't need to dump data into the storage and later on have to download that data into their laptop or their desktop. So if they don't dump their data, many of their data in the storage, then we will not have the issue of storage capacity. And then the second thing is the network bandwidth. The network, when they are visualizing data in the ZPC cluster, for example, it takes a lot of network bandwidth to do that. Do we have enough network bandwidth? I think currently we have a very reasonable network bandwidth. But if you centralized everything, then just have a package where someone can just simply dump the output of the application, and then that application and then get a visualization result or an image. Then it becomes much easier. And there are also a lot of things that are involved in a visualization system, rather than just simply having your own confined space. So the issue is about trying to save the computational resources that we have at the ZPC. So we want to bring new ideas, we want to bring sophisticated ideas, and instead of having a one way of like, no, we'll increase the storage in order to store the data. We increase it, we're going to increase the storage to 10 petabytes, but we'll have the same issues in about 1 year of storage capacity. So this is one of the issues that I have in mind that we should be able to tackle using the visualization system. Yes, Scott?
Okay, I don't know. Is there any way to plug USB-C into your projector so I can actually show something?
Yes, I think that can be done.
I would need a dongle.
Yeah. She can be able to assist us.
Luckily, I have a large phone.
Yeah.
So, because a lot of what you said, I can actually show. It's what we show in tutorials. And I will partially disagree with your answer, just coming from, again, a perspective of been there, seen that. So what I'll say is, I agree with you to some point, but what my belief is, and I've run like workshops in DOE for this.
Yes.
It's in the data reduction as well. Imagine that there's a way, because if I'm just going to visualize like I mentioned, like, oh, temperature. If you want to visualize, imagine there's a way that I can actually reduce that data by over a factor of 1,000 per step. So when you say petabyte, you have to remember, I deal with a lot more. I'm the bleeding edge guy at Oak Ridge. Okay, so I'm telling you, imagine that per, like, we'll call it step. So is there a way to plug this in?
Yeah, I think the lady is trying to set up
Because I would have to
the slides for
push
you.
the button here. So
Scott, can you please come in front? Yes, you can have a just
So
come
I
in
can't
front
plug
and then
it in?
yeah.
there's
Then,
just
you
no way I
can-
can show on a small screen like this.
I'm not sure about that.
You mean, okay, it's going to be hard here. Okay, this is going to be interesting. This is remote visualization. Okay. See if this works first. Well, here, let me go to this screen.
Okay. Can you?
Well, I need USB-C. Okay.
Oh, it's hot in here. Yeah.
No, that
Yeah. Yeah, it's hot. Yeah.
we're going to see if this technology works.
Let's see if we can have a remote visualization.
I'm not going to say this.
Oh yes.
No,
like it's
but
working.
no, I can't have Dex on. Okay, so let's try this. It's only going to use up part of the screen. There we go. And I apologize. I mean, this is actually some of the visualizations we did with Visit. And if you actually look at the numbers there, oh, thank you. This was actually 7.5 petabytes of data that we worked with. And I mean, this was like with Adios and Visit. The next thing I'm going to show you, and I'm just going to point out here, I know it's hard to see, and I apologize, but given what I'm working with, this is just run on a single node, but just trying to show you what I think we're talking about here. On the upper left window, where just upper left, that's where I'm going to run an MPI calculation. So I'm going to run a reaction diffusion equation. It's called Gray-Scott.
Yes.
The window that's below it, I'm going to launch as a separate MPI calculation to take data from that and actually compute a probability distribution function, or think of it as a histogram. The window that will be in the upper right, I'm going to run another job in Python. The window below that, I'll run a different job in Python. And the window below that, eventually, we're going to run with Visit. So I'm going to hit this button. And what you'll see, and thanks for holding, the upper window, it's increasing the steps. I'm going to launch the PDF. And now I'm using something like a new plot. And I'm looking at that. Then I'm running a Python visualization. And I'm seeing a 2D slice of this. Then what we're going to do is that we're going to run Visit, and all this, there's no files. So as I run Visit, you'll see I'm looking like I'm attaching to the file. It's doing 2 ISO contours, and you can see the data's changing in time.
All the time, yes.
No files are being produced. The visualization, the application wasn't written. It doesn't know anything about what we're visualizing. And if it's actually run on a cluster, it doesn't slow down. But now what we're going to show is that we just kill the visualization. We kill some processes. And then what we can do is we can just fire them back up. And then it just starts right back up from where you're at. No files are produced. Now you'll see we start Visit. And now we can just visualize the data. And now it just fires up. So this is what we call in situ viz, without slowing the calculation down. And just, again, you could do whatever you want, kill things, go. Application was never programmed. That's the environment I think you want.
Thank you.
Does that make sense?
Yeah, it makes sense. It makes sense.
Okay.
No. Is there any comment regarding what Scott has demonstrated to us?
Thank you.
Charles?
Thanks. How much of that is bespoke tools, and how much of that's knowledge that you've demonstrated? In other words, this is not special hardware. This is a special software stack, and this is knowledge of how to do this. Is that right?
There's software that's been developed, over the last 20 years. It's a large collaboration. In my talk, I'll actually mention part of it, but again, there's no special hardware. This is actually the one I showed. We just did that for a tutorial for everyone using VMware.
Yeah.
But we actually run that exact thing. So we run, there's a calculation, an MD calculation called DCA++, if you've heard of it. It's won 2 Gordon Bell Prizes. The total data that they actually generate is over 100 petabytes, or terabytes now from their calculation. We run with other fusion codes, one that was, I can't remember which keynote talked about some of the fusion codes and the importance in Intel, but there's a code called XGC. It's one of the most state-of-the-art fusion codes. And I'm one of the guys on the fusion project as well. But the point is, we use this all the time. It is software, but it's mapped to the hardware and the visualization components. And again, I can probably show another slide if I want to show it. But what we're trying to say is, imagine the world of where you have your application. It's a parallel. I don't care if it's done on one processor or for us, even a million. I don't care if it's GPU enabled or not. The software, though, for say the visualization services, want to be, if you have GPU hardware, GPU enabled. That's something called VTK-M. So are you familiar with VTK? So are you familiar with VTK-M? So that is the GPU or accelerator version, and that's led by Oak Ridge, Ken Moreland. And what I'm saying is now your visualization is now, instead of programmed directly with VTK, it's programmed in VTK-M, which is now that abstraction which hides the GPU layer, and then you program it. So now the visualization hardware, like ParaView, is taking advantage of that. And then there's the communication mechanism, which we say is coming through Adios, which just allows you to say, hey, instead of files, I can go to dev null, no files. I can go to separate nodes that you're running on the cluster. In JAXA, the Japanese aerospace, we've worked with them where they have their Fujitsu system, which is a tofu network. So then what we've done with them is they have a separate visualization cluster. So like when you give an answer to me, it's like, well, it depends. Sometimes you want to just have it on your laptop and you remotely connect. Sometimes you want to move small data to your laptop. Sometimes you want to use compute nodes on your system.
Correct.
Sometimes you want to have separate visualization systems that are locally or even remotely around the world. Like we work with the guys at Pawsey Supercomputing Center. So all those things, what you want is the correct abstractions. So then you're not programming for it directly. And that's the thing I'll keep advocating. There's no one single solution, but with the proper abstractions, then it's easy for the users. And I hope that's what I demonstrated.
Yes. Okay. Thank you, guys. I think we had a very fruitful discussion, or particularly about the kind of a software stack that we like to have in the visualization, and also the kind of few services that will also like to our users would like to have or be offered at the CHPC. So we had a very fruitful discussion, and then there will also be a follow-up email in future. If you see an email from us requesting more information, please do respond. And then because your input is very important to us, and we do appreciate that. And with that, I would like to thank everyone who attended this session. And then there's no any other question online, right? Okay. And yes, I think it is time for the break. And thank you very much.